I've already had these. Oh! How is it? How? No, not this. Oh, this. Yeah, this one might be worse. Yes.
All right, here we go. Okay, today is something that you probably have seen parts of in Algebra 2, but, yes, I'm stalking right behind you, Mrs. Blista, but you haven't seen them all. So here we go. We have the 12 basic functions today. What are the 12 basic functions? Well, they're graphs of the most used functions that we have in Algebra 2, Pre-Calc, AP Calc, and so on. Okay? Because when we study math, we see these over and over again, and we have to understand, oh, this looks like this. There's a pattern that develops. Okay? Math is a lot of patterns, so we want to do patterns. So, f of x equals x. You can always replace f of x with y, so y equals x is our first function. What's the slope of y equals x? 1. 1. What's the y-intercept? 0. So y equals x has a slope of 1 and a y-intercept of 0. Now, we can play with identity function. We can add numbers to it. So if I would go y equals x plus 4, what would happen to that function? It would go up 4. Okay. I could play with that function. I could make it y equals negative x plus 2. Negative x would actually make it go down, make the slope opposite and go like that. Okay. So we will play with these functions a little bit and modify them a little bit to get them to where we need them to be. Okay, the squaring function, y equals x squared. This makes a graph called a parabola. Parabola, not a parabola, a parabola. Okay, so if we have x squared plus 4, the graph goes up by 4. If we have x minus 4 quantity squared, the graph would shift right by 4. Okay, so that's that type of thing. Okay, so it depends how you change it, what happens to the graph. But our basic graph, y equals x squared, makes a basic parabola with a vertex at 0, 0. It goes through 1, 1, 2, 4, negative 1, 1, negative 2, 4, 3, 9, 4, 16, 5, 25, and so on. The cubic function, y equals x cubed, looks like that. Okay, so when you see that, it's a cubic function. It has an inflection point at 0, 0. It's an odd function. So if it's an odd function, if you take the mirror image across the y-axis and then mirror image across the x-axis, it should be on top of itself. Okay, that's what an odd function always does. If you mirror it across both the y and the x-axis, then it is there. The reciprocal function, we see this a lot. Okay, 1 over x. 1 over x is this. Okay. What number in math can you not divide by? 0. You can never divide by 0. So that's why it makes an asymptote on the y-axis. Because that x equals 0 is the y-axis. You can't have a point there. So it makes an asymptote. Square root function will look like that. Okay, know what the square root function looks like. It goes through 0, 0, 1, 1, 4, 2, 9, 3, 16, 4, 25, 5, and so on. Know what the square root function as a generally looks like. Thanks, Keisha. That's fine. Did you bring my block in, or did you leave it in the hallway for somebody to turn their ankle on? Thank you, Keisha. Exponential function. F of x equals e to the x. It goes through 0, 1, and 1, 2.7, 1828, 1828, 50, no, 9045, 459045. That point right here is 1, 2.7, 1828, 1828, 459045, yada, yada, yada. I am not making numbers up. If you look up Euler's number on the internet, bet you I'm right. How do I remember that? Because Andrew Jackson. Andrew Jackson. Oh gosh. Andrew Jackson. Well, I was trying to think. There's two presidents involved. Andrew Jackson and Garfield. I forget. James A. Garfield? Both presidents of the United States. Andrew Jackson. What president of the United States was he? Any clue? 7th president of the United States. Yeah? How many terms did he serve? 2 terms. When was he first elected? What was the election where he was first elected? What did you say? Thank you very much. 2 terms, 7th president, 1828, 1828. President Garfield was a closet mathematician. He liked to do geometry proofs. He did a proof of a 45, 90, 45 triangle. And that's how history is tied with mathematics. That's how 2 presidents are tied to Euler's number. That is so cool. It is so cool. All right. But Euler's number, an exponential function, the basic exponential function looks like that. Okay? That deals with, all right, natural log. A natural log is the inverse to y equals e to the x. They're inverse functions. So, at 2.718281828459045, the x value is 1. Because they're inverse functions. You just flip the x's and the y's around. Because if we go back to this one, we had the point 0, 1. Here we have the point 1, 0. Just flip the x's and the y's around on inverse functions. They're inverses of each other. The sine function. Everybody in here took trig, right?
Yeah.
Poor Carson.
Oh, I'm not the only one.
You have not taken trig yet, huh? Oh. That is so horrible. I don't know.
I don't know why they let me in this class. It feels unfair.
It is totally unfair that you're in here. I think Algebra 2 is a prerequisite for this class, so.
It's not. There was nothing there.
But yeah, she shouldn't have. But you know.
Anyways.
But you know, they're smart. They can handle it. Yeah.
But it's true. It's true.
All right, the sine function from trig. Obviously, it's a sinusoidal function that goes up and down and up and down and up and down. Okay, it's a basic graph that starts at the point 0, 0, and at pi over 2, we're at 1. At pi, we're at 0 again. At 3 pi over 2, we're at negative 1. And at 2 pi, we're back at 0. Keeps going, and it just follows that pattern over and over and over and over and over again. Okay, the sine function. Guess what the next function is? Oh, look at that. It's the cosine function. The difference between the sine and the cosine function, you just slide over the sine function and it becomes a cosine function. So it starts out at 0, 1. Then you have pi over 2, 0. At pi, we're at negative 1. At 3 pi over 2, we're at 0. And at 2 pi, we're back at 1 again. And then it just keeps repeating itself. So that was chapter 2 of trig. This is pre-calc, not trig, but I just went over chapter 2 of trig right now in the last minute. Absolute value function, which those in Algebra 2 will learn about Thursday and Friday. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of negative 1 is a positive 1. The absolute value of negative 2 is a positive 2, and so on. so it makes a b. Absolute value functions always make a b. Okay? So you saw this in Algebra 2, hopefully, quite a bit. This one's something different that many of you have not seen. It's called the greatest integer function. Okay? So anything in between 0 and 1 truncates down to 0. Molly, you don't have to constantly make comments about everything. Anything in between 1 and 2 truncates down to 1. So at 2.46957, yada, 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 its y value is 2. You just cut off the decimal. You don't round, you truncate. So at 3.998946, it truncates to 3. But at 4, it goes to 4. Okay? It's a jump. You jump from one to the next, so it's not a continuous function. It's discontinuous, and it's called a step function because it has a jump discontinuity every integer. Okay? Now, this is something you don't see very often. Okay? Will be on the ACT test? Probably not. Okay? But you'll see it every now and then. You have to know it. This one is the least of any that you'll see. It's called the logistic function. Now, this does happen in nature. Okay? It's like overpopulation of animals. Okay? Once the population of something gets so high, it flattens out because there's not enough food to feed it. Okay? The earth can only support so many human beings until, we couldn't produce enough food to feed everybody, and then the population of the earth would flatten out. Hasn't gotten to that point yet. Okay? But that is the logistic function. Okay? Its equation's rather weird. Okay? It's one that I struggle to teach with a little bit because it's just not used that often. Okay? But it is one of the 12 basic functions. All right, so those were the 12 basic functions. So, of those 12 basic functions, which function has a domain of all real numbers except for 0? Which function has a graph that doesn't have 0 in it? The reciprocal function, the one that looks like this, the 1 over x. So you'll be answering questions like that today, okay? Like looking at the graphs and figuring out, oh, which one is that? Okay? All right, if we look at this function, what is this most like? What is that function most like? Y equals x squared, the parabola function. What does this in front of the x do? Flips it upside down. What does this do if it's not in parentheses inside the squared? Whoa, didn't mean to do that. Don't know what I just did. Now I screwed things up because I don't know how to fix that. Okay, go back. All right, there we go. All right, so that moves everything down 1. So that's down 1 vertically. This is flips it. Okay. All right, so if it's like that, where's the function increasing? Where is it getting bigger? From where to where? Negative infinity up until 0. So where would it be decreasing? 0 to positive infinity, because we're looking at this function. Is it odd, even, or neither? It's even because it reflects around the y-axis. Okay. Does it have any extrema? Does it have a max or a min? It has a max. Where is the max located? Now, normally, if you had y equals negative x squared, it would be at 0, 0. But because we shifted down by 1, where's the max at? 0, negative 1. So if we know the properties of the basic function, we can answer other questions because we know those original properties. Flips upside down, down by 1, but it's the same as what this would be. How does the graph relate to this basic function? Well, it's the reciprocal, or not the reciprocal. You flip it upside down, so it's a mirror image across the x-axis, and it translates down by 1. So they answered those questions. Okay, discard. All right, so what will your homework look like today? It will look like this. Zoom. This is a slight variation of one of the 12 basic functions. Which function do you think it's a slight variation of? The cubic, y equals x cubed. It goes up from the y equals x cubed. If it goes up, Should it happen inside the parentheses or outside the parentheses? It should happen outside. So which of these is a cubic function? Well, it's not this, 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 not this. It's got to be A or E. Which one happens on the outside of the parentheses? E. Okay. Which of the 12 basic functions does this most appear to be like? Y equals x. Y equals x. But since it's decreasing, this would be y equals a negative x of some sort. Okay? So it's not this one, 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 not this one. So it's not this one either. So it must be y equals negative 2x. Okay? We eliminated what it couldn't be, and then we found what it would be. Which one does this look like? Y equals x cubed. Looks like a cubic function. Looks like a cubic function. So I'll get rid of all the non-cubic functions. Now, what happened? It doesn't go through 0, 0. It slid this way. If it slides that way, does it happen inside the parentheses or outside the parentheses? Inside. The x plus 2 moves it to the left. Okay, out of all these functions, which excludes 0? Can you have 0 in this one? Can you have 0 in a square root function? Yeah, square root of 0 is 0, so it's not the answer. Can you have 0 in a cosine function? Yup, so it's not that one. Can you have 0 in the greatest integer function? Yup, you can. Can you have 0 here? Yes, you can. Can you have 0 here? No. So that's 1. Can you have 0 here? And actually you can. You can have 0 there. You can have 0 there. You can have 0 there. 0 is there. 0 is there. And 0 is there. So it's only one answer. Just E. Then, this function... Whoa! Go back. Go back. This function is like which function? Y equals x squared. So it should be a parabola. You get rid of this, you get rid of this. The coefficient of the x squared, is it positive or negative? Positive. Since it is positive, the parabola should open up or down? Up. So you know it's this graph right now. That's knowing what your basic functions look like. What's the domain of the function? Is there anything that would restrict this domain? No. So it's all real numbers. So in interval notation, it goes from negative infinity to infinity. That's interval notation. Okay? Parentheses always go with infinities. Always, always, always. What's the range of the function? Well, what's the lowest number that can be used here? Negative 5, because everything goes down from 0, 0 all the way down to 5. So negative 5 is the lowest function that can be used, and it is used. So since it is used, it has a bracket, not a parenthesis. And it goes up to infinity. Infinities always have parentheses. If you use the number, it gets a bracket. If you don't use a number, but it goes really close right up next to it, it uses a parenthesis. Since infinity is not a specific number, we always use parentheses with infinities. Which one does this most resemble? Well, the ln, I would say f of x equals the ln of x. Looking at your 12 basic functions that you guys sketched in your notes, oh, some of you didn't do that? Oh, you poor people, you should have maybe done that. Looking at the 12 basic functions that you sketched in your notes, which one most resembles the ln of x? A, B, C, or D? A or D. Okay, A or D. The natural log function goes up like that. Now, what does the negative 1 do? Well, it happens in parentheses. If it happens in parentheses, you do the opposite of what you think. It shifts the x values 1, and it would go the opposite of what you think. So a negative 1 would go to the left, but since it's minus 1, it actually goes to the right by 1. So it would be D. It would be D. Because the natural log function, the natural log of 1 equals 0. So if you go 1 to the right, that's the way it would be. All right. So what's the domain of the function? Is it all real numbers? No, it is not. Okay. Natural logs form an asymptote with the y-axis. So this is y equals the ln of x. Forms an asymptote with the y-axis and goes up like that and goes through the point 1, 0. Okay. So this is just shifted over 1 from there. So if it's an asymptote with the y-axis, okay, then it doesn't there's no numbers to this side of it, so the domain for this one is from 0 to infinity. So on this one, if we slide everything over 1 to the right, it would be 1 to infinity. The range of the function goes all the way down, and since it goes up, it just continually goes up forever. So it's negative infinity to infinity. Now this reminds me of, I might have made an oops up above. I might have made an oops up here somewhere. Where is it? Oh, this one. The natural log, is a natural log function here? Nope, there's no natural log, so I think I had the right answer. But a natural log function is one that does exclude 0. Okay. Greatest integer function, 3x over 4. Ooh, okay. What does that look like? Well, if you put in a 0, you should get 0. If you put in a 1, you get 3/4. What's the integer that goes with 3/4? Well, it's 0, because you truncate down. If you put in a 2, you get 6/4. 6/4 is 1/2, which truncates down to 1. Put in a 3, it's 9/4, which is 2, and so on. So you want 1, 0, you want 2, 1, you want 3, 2, and so on. Well, that looks like it's choice C. What's the domain? Well, you can use any number here, so it goes from negative infinity to infinity. But since it's a greatest integer function, it's just the integers. Just the integers. How many more we got? We got a couple more. This one, what happens to this? Well, on this, everything happens to the inside, okay? So it's 5 times skinnier and moves 2 to the left, okay? So it goes skinnier and to the left, so it's choice B, okay? What's the domain? Well, you can still put any number in there, so it's all real numbers, so it's negative infinity to infinity. What's the range? Well, it hits the y-axis, right? So it includes 0, and it goes up from there, 0 to infinity. Okay, then you're going to see these, and you're just going to have to answer the questions. Which one would be the correct graph? Well, it happens outside the absolute values, so it's a vertical shift. So it's a vertical shift up by 2. Where is it increasing? Well, it's increasing after the point here. So it's increasing from 0 to infinity. I think I'm right. Let me run down to the answers for number 9. I think I need to use parentheses there. 9. There he goes. 0 to infinity. Nope, not parentheses. See, I don't agree with that. I don't think it's increasing at 0. I think it's constant at 0 and starts increasing just after 0. But that's the wrong answer. Starts increasing at 0, so you include 0. And then it's decreasing from negative infinity up to 0. Okay? Is the function odd, even, or neither? Does it have a mirror image across the y-axis? Yes, so it's an even function. It's an even function. Does it have extrema? Does it have a lowest point or highest point? Yes, it has a minimum value. It has a minimum at x equals 0 of 2. As a minimum. Okay. The function is an absolute value function. And it shifts vertically up by 2 units. Okay. So you have some questions like that. There's another one that's really like it. And this one. What are the horizontal asymptotes here? Well, it looks like there's one at 3, and then there's one at negative 3. Okay, that's a logistic function. So there are 11 problems on your first assignment today. So you can get busy with those. I will put it out there in a second.